everyone. Today we are going to discuss about industrial open loop and closed loop control systems. First of all, what is control system? A control system is defined as a system of devices that manages, commits, directs or regulates the behavior of other devices or systems to achieve a desired result. A control system achieves this through control loops, which are a process designed to maintain a process variable at a desired set point. In other words, a definition of a control system can be simplified as a system which controls other systems. As human civilization is being modernized day by day, the demand for automation has increased alongside it. Automation requires control over systems of interactive devices. Okay. And this we have two types. The first one is open loop control system, second one is closed loop control system. In recent years, control systems have played a central role in the development and advancement of modern technology and civilization. Practically every aspect of our day-to-day life is affected more or less by some type of control system. Examples of control systems in your day-to-day life includes an air conditioner, a refrigerator, an air conditioner, a bathroom toilet tank, an automatic iron and mini phones within a car such as cruise control. In industrial settings, we find control systems in the quality control of products, weapon system, transportation systems, power systems, space technology, robotics and much more. Okay. The principle of control theory are applicable to both engineering and non-engineering field. You can learn about anything, and in this we have features of control system. The main feature of a control system is that there should be a clear mathematical relationship between the input and output of systems. When the relation between input and output of the system can be represented by a linear proportionally, the system is called a linear control system. Again, when the relationship between input and output cannot be represented by a single linear proportionally, rather the input and output are related by some other non-linear relation, the system is referred to as non-linear control system. Okay, and what is the requirement of a good control system? Okay, in open loop control system we have so many real-time examples. In this we have washing machines, traffic signals. Note that any control systems that are operates on a time basis are open loop. Okay, and this we have to consider accuracy, sensitivity, mainly. Here the accuracy is a measurement of tolerance of the instrument that defines the limits of the errors made when the instrument is used in normal operating conditions. This accuracy can be improved by using feedback elements. To increase the accuracy of any control system, error detector should be present in the control system. And thus we have sensitivity. The parameters of a control system are always changing with the change in the surrounding conditions, internal disturbance or any other parameters. This change can be expressed in terms of sensitivity. Any other control system should be insensitive to such parameters but sensitive to input signals only. Okay. And thus we have some more parameters like noise, stability, bandwidth and speed. Oscillation. We have various types of control systems, but all of them are created to control outputs. The system used for controlling the position, velocity, acceleration, temperature, pressure, voltage and current, etc. These are the some parameters of control system. Let's take an example of a simple temperature controller of the room to clear the concept. Suppose there is a simple heating element which is heated up as long as the electric power supply is switched on. As long as the power supply switch off, the heaters on temperature of the room rises, and after achieving the desired temperature of the room, the power supply is switched off. Again, due to ambient temperature, the room temperature falls, and then manually the heater element is switched on to achieve the desired room temperature again. In this way, one can manually control the room temperature at the desired level. This is an example of a manual control system. This system can further be improved by using a timer switching arrangement of a power supply, where the supply to the heating element is switched on and off in a predetermined interval to achieve the desired temperature level of the room. Okay. Okay, there is another improved way of controlling the temperature of the room. Here, one sensor measures the difference between actual temperature and desired temperature. Both forms of the systems are automatic control system. In the former one, the input of the system is entirely independent of the output of the system. The temperature of the room, that is the output, increases as long as the power supply switch is kept on. This means the heating element produces the heat as long as the power supply is kept on, and the final room temperature does not have any control over the input power supply of the system. This system is referred to as open loop control system. Okay. And this error signal is fed back to the system to control the input. As the input to the output path and the error feedback path creates a closed loop. This type of control system is referred to as closed loop control system. Okay, here we have two main types of control system: open loop and closed loop control system. Okay, now we have some practical examples for open loop control system: electrical hand dryer, automatic washing machine, bread toaster, automatic tea coffee maker, time-based clothes dryer, light switch, and volume and stereo systems. Okay, and also we have so many advantages in open loop control system. It is simple in construction, economical, easy to maintain, generally stable, and it is very convenient. And also we have some disadvantages like inaccurate, unreliable, and it cannot correct any change in the output automatically. And we have closed loop system. To overcome this inconvenience in open loop, we have closed loop control system. And thus we have some examples for like automatic electric iron, servo voltage stabilizer, water level controller, missile launcher and auto tracked by radar, and air conditioner, cooling system in car. And we have so many advantages in closed loop control system, like it is more accurate, and it has feedback for error correction where the bandwidth range is large. It facilitates automation, and also the sensitivity of the system may be made small to make the system more stable, and the system is less affected by noise. Okay, that's all about closed loop and open loop control system in industries. And also we have discussed about closed loop and open loop control system in real time. Thank you.